Hello and welcome to this video where I'm going to do an exam walkthrough of the OCR exam paper from Wednesday the 15th of May 2024. So it's for GCSE Computer Science and the code is J27701. Okay, so before we actually start looking at the questions, one of the things that I'm always trying to tell my students is that you must look at the mark scheme when you are doing past exam papers. You will learn so much about what the exam board are looking for, and part of sort of prepping for exams is that you know the style and what the exam board are looking for when you answer the questions. So let's just have a look at the mark scheme. So here, there's lots of stuff here for instructions for the person who's marking it. What I'm going to just show you here is subject-specific marking instructions. And what that means is how exactly do they award the marks for what you've written? And there's a few important things here because we will be looking at the mark scheme. So the first thing is, it says here, each mark point is worth 1 mark unless stated otherwise. So it's just 1 mark unless it says each mark point can only be awarded once. Underlined phrases need to be exact to get that mark point. So we will see that in the mark scheme. And if something is in bold, then the concept needs to be in the answer. So you could talk about, I don't know, file compression. And if compression was in bold, then you can talk about it in a number of different ways. Like you could say it makes the file smaller by removing things or that type of thing. One of the things that is really important is this thing where we've got 3 dots. So 3 dots at the end of a mark point and at the start of a second one means you must get the first one before you get the second. So what does that actually mean? Let's have a look at the mark scheme and I'll show you. So if we go down a little bit further, we can see this one here and it says it allows a larger number of connections devices, more scalable ... and then underneath ... without the disruption cost of installing more cables. So you cannot get without the disruption cost of installing more cables mark without putting something above that that gives you the mark allows a larger number of connections devices, more scalable. So, well, like I said, you know, there's lots of examples of this. The other thing that I just wanted to say was, yeah, the 3 dots at the start of a mark point without 3 dots at the end of the mark point means there's no carry on. So if we look at an example of this in the mark scheme, we can see here, here's an example, we've got ... and you don't have to have got the ... So you don't have to have got the one above because there's no ... at the end of it. So there's a few nuances here that you really need to be aware of when you're marking your own work. And because it's really important that you look at the mark scheme. I can't emphasize this enough. It's not cheating if you don't know the answer when you're revising, and it will really elevate your marks if you look at that mark scheme to see what they're after. So anything in brackets is optional. You don't have to get it to get the mark point. And a single slash means it's an alternative word. A double slash means it's an alternative statement. So you just get 1 mark for it though. So it's like or basically. Enlarged font is for visibility reasons only. Okay, so we have looked at that mark scheme. Let's now start looking at the paper and walking through the paper. So there's no calculators, main reason being that you'll be asked to do some binary, hexadecimal conversions to denary, and lots of calculators can do that for you. 80 marks for the entire paper. Let's have a look. First question, 3 marks. The following table has either the binary or denary values of 3 numbers. Complete the table by converting the 8-bit binary number into into denary and the denary number into 8-bit binary. So it's really important, actually, it says, as we'll see shortly, that you only use 8-bit binary for this. So let's convert that first 8-bit binary number, and I'm just going to write the headers above it. It's going to be a little bit tricky to sort of fit them in. 128, 64, 32, and then this one here is 16. And then we've got 8, 4, 2, and 1. So we add up the numbers where there's a 1, we ignore the ones that are 0. So we've got 128 plus 64 plus 32 plus 16, and that is 240. So we put 240 there. Our next question is we're going to convert 105 from denary into binary. So I'm going to write the headers here: 128, 64, 32, 16, 8, 4, 2 and 1. Okay, so 105 is too big, is too small to go into 128, so we put a 0 there. But we can switch 64 on, so we can do 105 minus 64, and that is 41 left over. I'll just write 41 here. So 105 minus 64 is 41, and then we could switch 32 on, so that would be 41 minus 32, and that is 9 left over. So 16's too big. 8 isn't though, so we can switch 8 on. 9 minus 8 is 1, so we can then switch that 1 on there. And remember that an odd number, 105 is an odd number, so the 1 column must have a 1 in it, and that is correct. So we can just leave our answer there. Okay, let's do the final question. And this is just adding up some binary again, looking for the ones. So we've got 128, 64, 32, 16, 8, 4, 2, and then 1. So we've got, what have we got? We've got 16 plus 8 plus 4 plus 2. So that's 16 plus 4 is 20. 20 plus 8 is 28, so it's 30. So the final answer is 30. So nice 3 easy marks for doing a bit of binary to denary conversion. And we can see the answer here. And it says their binary must be 8 bits. So just make sure you always stick to what they're asking for. So on to the next question. Complete the table by writing the answer to each statement. The smallest denary number that can be represented by a 4-bit binary number. Now they've been a bit sneaky with this question. By the way, at any point if you want to try and answer these yourself, do just pause the video. But the smallest denary number that can be represented by 4-bit binary, if we've got 4 bits, well, it's 0. So it's always 0. Obviously the largest one is completely different. If we were looking for the largest number with 4 bits, that would be 15, but they're looking for the smallest denary number. The largest denary number that can be represented by 6-bit binary. So if we add our 6 bits, we've got 1, 2, 4, 8, 16 and 32. And if we add those up, put a 1 under each, and we add them up, then the answer is 63. Now obviously that's 1 less than the next column, which is 64. So in order to have 64 in binary, we would have that. So this pattern goes on with every column. So yeah, anyway, the answer is 63 for the largest denary number with 6 bits. Then the maximum number of different colours that can be represented with a colour depth of 7 bits. So if we think about our 7 bits, we just saw that a moment ago. We had 64, 32, 16, 8, 4, 2 and 1. And if we have a 1 in all of those 7 bits, then that gives us 127, but we can have 0 as well, so it's actually 128. Then the final question, the minimum number of bits needed to represent 150 different characters in a character set. So if you think about this, we've just seen actually that if we had 7 columns, then that would give us the highest number is 64. And we have the other ones as well. So 64, 32, 16, 8, 4, 2, 1. Well, that gives us a maximum of 127 if they're all on. So that's not going to be enough. We've got 150 different characters. So we're going to have to add another column, the 128, and that will let us go above the number 127. So we can see here in the answers, there's our answers, except, and it also says in the guidance, accept calculations that equate to the same answer. So you can put the answers in, the equation in. accept any number of zeros for the first answer. So if you'd put for the first one 0, 0, 0, 0, so 4 zeros because it's a 4-bit binary number, that would have been okay. Okay, on to the next question, and it says show the result of a left binary shift of 4 places on the binary number 0, 0, 0, 0, 1, 1, 1, 1. So with this question, all we're going to do is shift everything, just the ones basically, ignore the zeros, 4 places. We'll do it one at a time though. So then you'll see what's going on. So 1, 2, 3, 4, there's our binary number. We're going to shift to the left 1 time. So we just do a 0, 0, 0, and then we're shifting that 1 here to the next column. So that's a 1, and the same for this one, that's a 1. And we carry on until we've got our 4 ones, and then we just fill in a 0 on the end there. So that's our first shift. We do the same for the second shift. There's our 4 ones, and we fill in 2 zeros because the 4 numbers have shifted again each time. Our third shift is going to give us this. There we are, we fill in again, and then our final 4th place shift is going to give us this number here. So you can see each time we're just shifting everything 1 column. So our final answer is 1, 1, 1, 1, 0, 0, 0, 0. If we look at the mark scheme, we can see there's our number and it says ignore leading zeros, but you shouldn't have to, you shouldn't have to put those in anyway. So our next question, describe how to convert a 2-digit hexadecimal number into denary. Use an example in your answer, and there's 3 marks for this. So there's a couple of ways you can convert hex to denary. The first way is if you've got 2 digits especially, then you can take the first digit. So say for example we've got a 1 and then we've got a, for example, then what we could do is take the first digit there and we times that by 16. And then we take the second one here, which is 10, and then we just add that on. So we don't times it by anything because it's the units column. So basically that's 10 plus 16, which is 26. So we would write a sentence to say, take the first digit, times it by 16, and then take the second digit and add that on to the result of the first digit. Now another way that you can do this is my preferred method because it's a lot easier than timesing by 16, especially if you don't have a calculator. Then the other method is to convert each number. So if we had the 1, so we had the 1 and we had the A. So we take each digit and we convert that into binary. And we do the same for the other one. That's 10. A is 10, so that's 8, 9, 10. We combine the numbers, so we push them together. So the 2 nibbles there, we combine them and then we restore proper headers. So that would be a 16, 8, and then 2. And 16 plus 8 plus 2 is 16, 17, 18, 18, 19, 20, 21, 22, 20, 24, 25, 26. So that's the same as we had up before. Obviously it works both ways. So we're just describing that, but it does say give an example. So just make sure that you give an example in that. And you don't have a massive amount of space here, so they're not asking you to write an essay. Just try and be brief, but fully explain as well. So if we have a look at the mark scheme, there are a few things that they're looking for here. It says no marks for converting denary to hex. If the example has an accurate result, for example, they have converted, inaccurate result, for example, they've converted A to 11, they can still get the method marks. No requirement to show how letters are used. So yeah, and again, obviously the main mark scheme here we're just describing is showing the 2 different ways to convert between binary and denary and hexadecimal. Okay, Next question. This is adding binary. So add these two 8-bit binary numbers using binary addition. Show you're working out. So we are just going to use the rules to add binary. So they are 0 plus 0 is 0. 0 plus 1 is 1. So those are just the same as denary. You don't have to remember those because it's just the same as denary. And then we've got 1 plus 1 is 0, carry the 1. And then we've got 1 plus 1 plus 1. And that is 1, carry the 1. So those are the sort of the last two rules there. Those are the ones that you're going to have to remember. Okay, so our first column here, we've got 1 plus 1. So that is a 0, and we carry the 1. Then we've got 1 plus 1 plus 1 in that column here. So we use the fourth rule, that's 1, and we carry the 1. Then we've got 1 plus 1 in the next column, so that is 0, carry the 1. 1 plus 1 plus 1, so that's a 1, carry the 1. 1 plus 0 plus 0, well, that's the same as this one here. It doesn't matter how many zeros you've got. So that's just 1. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 0 is 0. So that is the answer there. So if we look at the mark scheme, we can see here we've got the same answer there, and we've got the carries as well. So just make sure that you put those on. So it's 1 mark for the correct answer with 4 carries and the correct answer. And it does say do not award working mark for conversion denary to denary and back. So if you converted the two numbers, added those, then they won't give you a mark for that. And the carries must be on the correct values, but could be above or below. So I put them above, you could put them below, doesn't matter where you put them. So I hope by now you can see why it's really important to look at the mark scheme, because there are things that, you could potentially do in your answer, for example, converting to denary and back, thinking that's going to give you your marks when it's not actually going to give you those marks. Okay, so the next question. An airport has computers that are connected together on a local area network. Each computer has an IP address and a MAC address. Give one valid example of an IP version 4 address and one valid example of IP version 6. So with IP version 4, we've actually got 4 groups of denary. And the convention is that you can't have a number that's higher than 255. So if you had a number like 422.1.2.3, then that would not give you a mark because that's higher than 255. And that's a key thing about IP version 4 is you can't have any numbers higher than 255. So let's do, I don't know, just pick one. I'll pick 192.218 and then 4.1. None of the numbers are higher than 255, and I've used dots in between the 4. And then with IP version 6, we're using hexadecimal instead of denary. And the easiest way to remember this for the exam would be just to have 8 times 4 digits of hexadecimal. And you can just literally make anything up. I would try and not be too sort of F, etc. Just try and be a bit creative with it. But you could have sort of 0, 4, 2, A, and it doesn't matter if you use uppercase or lowercase in your hex, B, C, F, D, and then a colon. So we're doing 8 of these. So 0, 4, 9, A, and then a colon. So that's 3. We need 8 of these, so we might be here for a while. A, B, 9, 4. That's 4. So we're halfway there. I might need to go to the next underneath. That's okay though, because they're giving you 2 lines. And then, just trying to think of numbers on the fly. 7, 7, 7, 9, and then a colon. 4, 1, 9, 2, and then a colon. So we need 8 by 4. So we've got 1, 2, 3, 4, 5, 6, 2 more. I'll just do it on the next line below. A, F. We haven't used E yet, have we? E, E, and then E, E. My graphics tablet is not liking this at all. 8, 4. So 1, 2, 3, 4, 5, 6, 7, 8. So it's just the easiest way. Now there are rules, as we'll see in the mark scheme, to do with IP version 6. So if you can remember these, that's a great idea. However, if we look here, we can see that you can have double colon. If we look at this line here, you can have double colon, which basically is the same as having this expanded, so lots of zeros. So what I would do, and you can have, it says double colon can appear once in the IP address and replaces any number of groups of consecutive zeros. So that's absolutely fine to do that if you can remember it, but it's just easy. I always find it easy to remember 4 times 8. And it does say version 6, each hex number can be between 1 and 4 digits. So you can actually have 2, but I've just obviously just stuck with the main one. So you can see here's 2 digits there. You would just pad them out with zeros. So that's all it would do. Okay, so yeah, version 6 quite complicated, but obviously it needs to be, well, there's just rules, and you know, if you want to try and save your time revising things, then just stick with a 4x8. So the next question, describe the format of a MAC address, and there's 2 marks for this. So remember, MAC address, media access controller, they're not asking you that, they're asking you to describe the format. So very set format, it's hexadecimal again. So if we're doing a MAC address, then basically we've got the manufacturer number, and then we've got the serial number for the device. And remember, a MAC address is set at manufacturer, and it identifies you on a network. So what I would say is that, you know, obviously we've got 6, minimum of 6 times 6 hexadecimal digits for the first part, and for the second part, for the manufacturer part, and then for the second part, for the serial part, there's another 6. So it's 12 hex digits altogether. So we could put that 12 hex digits. And we could say also that it's separated by colons. Some people use hyphens, but most people use colons. And so that would get you 2 marks, but we could then explain. I'm just going to add some more in case you wanted to put this. So we could say, do an example. So we could say D, D. That's our first set of digits, a colon. So it's very similar to the IP version 6, but it's less digits. It's 12. So we've got D, D, E. I'm mixing uppercase and lowercase here. I'm aware of that. Probably shouldn't have done it, but 09. So that's our manufacturer number. So I'll just draw a little line here and say that's the manufacturer number. And then the next set of digits is the serial number. So I'm just going to make those up again. So 9834 AF. And that is the serial number. Okay, so that is describing the format of the MAC address. Let's have a look at the mark scheme, because there is a couple of other interesting things that I haven't mentioned. So it's usually represented in hex. We do normally have it in hex. They've got denary or binary. Obviously, hex can be converted to binary, and the whole point of why we use hex is so that we can read binary in a better way. So it's 6 groups of numbers, or 12 hex. Each group is paired in 2 digits, or is an 8-bit binary number, which is 48 bits long. We separate it by colons or hyphens. The first part is a manufacturer ID, and the second part is the serial number. So it just says there in the guidance, numbers is NE. If you see NE, it means not enough. So they want you to be specific. Is it a hex number, a denary number, binary number? And it says allow both marks for a valid example. So we could have just put that example. For example, 6 pairs of numbers gets mark 0.2. So that's that one there. And 4 pairs of numbers gets mark 0.3. So yeah, you could get that one too. Okay, so next question. The airport currently has wired connections for their local area network. Describe 2 benefits to the airport of using wired connections in their network. So, wired networks are really important. Let's have a look at the mark scale. Pause the video if you want to try and answer this. The main things are the security and speed if we're using a wired network. But we need to expand that out because it says describe 2 benefits. So we need to describe what it is, but why is that going to help? Why is a faster connection going to help? Well, it means that, if you've got faster computers, if you've got faster things going on in the airport, then all the screens that are used to sort of update the flights, etc., it's going to be faster, more accurate for the passengers so they don't miss their flights. And security-wise, you're not going to get people trying to hack into a Wi-Fi. Also, snooping on the network as well. So if you have software like Wireshark, which can read the packets on a Wi-Fi, that's not going to happen with a wired network. So anyway, let's have a look at the other things as well. So we've got faster connection speed. So yeah, just what I said there, faster connection speed, always with a wired network, to reduce delays at check-in, or you can just give any example for an airport. So like I said, with the flight displays, for example. Secure is unlikely or less likely to be hacked because they have to get into the wires so that the data about passengers, staff, aeroplanes are not intercepted. Or other example, little interference. So yeah, Wi-Fi doesn't go very far on its own. It gets, brick walls and things do stop it. Obviously, if it's a newer airport, that probably won't be quite an issue, but it does matter. And then long-range transmission. The airport has large floor terminal airports, then you're going to need a lot of boosters. And if one of those boosters fails on your Wi-Fi, then wired network's going to be the best approach. So if we're looking at what they're saying for the marking, mark in pairs, mark each benefit space to the candidate's benefit. An expansion of application for a benefit can be awarded in the other answer space. So if you have another benefit that could be used for another bullet point, then that's fine. Maximum 3 marks if expansions have no direct application. So basically just make sure that you fully expand each one of those reasons. So it's fast, why, how is it going to help the airport? It's secure, how is that going to actually help the airport and the passengers? There's little interference, it's more reliable. Then how is that going to benefit them? You get the idea. Now, next question, wired networks are fine, but explain the reasons why the airport should also allow the network to be accessed using a wireless connection. And we got 3 marks for this. So different reasons. Why is it going to be beneficial to the airport to have a Wi-Fi as well? So let's look at the mark scheme. If you want to carry on, you can pause the video and answer this question. I do recommend it if you can. But basically, if you need to move around, you've got staff that are moving around, then they're not going to be able to take their computer with them. So if you've got an iPad type device or tablet computer, they're not going to be able to use that anywhere else. Staff can be more responsive to customer requests, allow a larger number of connections and devices. Some devices don't allow for physical wired connections like tablet devices really, and therefore you can have a wider array of different types of devices. It's easier to add or connect more devices. You don't need to find a physical connection, and you can use it for backup as well if the wired fails. Now it does say e.g., so if you can think of something else, if you've got another answer but it clearly shows that it's beneficial to have Wi-Fi, then you can add that in. And it does say here, do not award cost on its own, do not award range on its own. So cost, how much the Wi-Fi is usually cheaper because you don't have to buy cables and you don't have to install it so much or install those cables. And the range, obviously we covered about that before, where in the previous question, where wireless does have a limit and you have to have boosters. Allow explanation of how a wireless network will benefit the passenger as well as the staff, and allow in reverse if clear. So wired restricts staff to one location. So that's absolutely fine to do that. So the next question is, one office in the airport has 5 computers connected to one switch. There are 2 printers in the office that can be accessed by all computers. The computers are connected using a star topology. Draw a diagram to show how the 5 computers, switch and 2 printers are connected in a star topology. Okay, so I'm just going to zoom out a little bit there and draw this. So basically we just need the switch in the middle. You don't have to do any fancy graphics, just do a box, and we clearly label that as the switch. And obviously it's not a Nintendo Switch, it's a switch that is a network controller. A switch is kind of similar to a router, but is not quite so intelligent at routing things. So we've got 5 computers, so we're just going to draw those on, and they're all connected individually to the switch. I'm just going to label it C. I would probably put the full word computer, but as you can see, my graphics tablet is a little bit slow, so I'm just going to put a C for computer. It's a little bit irritating that it's a little bit slow, but I can't get it to work any faster. It's the software that I'm using to record this. It's not the fastest. So 1, 2, 3, 4, and then we have another computer, and then finally we have 2 printers. So I'm just going to put those, P for printer, and that's connected to the switch individually as well, and a second P there. So that's our star topology, because it does kind of look like a star. Everything is connected to one central switch or a router, or it could be a hub as well, but in this case they've specifically said it's a switch, so make sure you put that. And we've got 8 things connected, 1, 2, 3, 4, 5, 6, 7, 8 items on there. Let's look at the mark scheme for that. And the mark scheme, it says 5 computers, 2 printers and 1 switch, all clearly labelled. So like I said, don't put C like I did, put computer. All devices directly connected to the switch, so a line. All computers connected to a switch, and each printer to a switch or computer. So in other words, you can connect a computer directly to a printer, but all printers must be, as I drew there, only 8 devices and no additional connections to that switch or central device. In the comments it says, allow any type of computer, e.g. PC or laptop, do not accept client for computer, and there must be at least 5 computers, at least 2 printers and 1 switch. So the next part of this question, give 1 benefit and 1 drawback of the office using star topology instead of mesh topology. Remember, with mesh, you're joining every computer to every other computer. So the benefit would be, or one of them would be, that if you wanted to add another computer, it's really easy. You just plug it into the switch, or you've got another device or server, you just plug it in. A drawback would be if that switch goes down, then the whole thing goes down, the whole network goes down. There are other benefits as well. So they've got here, so I've got it's easier to add new nodes. The central device can monitor and control transmission, so for things like a firewall to help prevent hackers. Faster data transmission, it is faster than mesh. Fewer data collisions, so that's where the messages sort of interrupt each other on the line. One connection computer breaks, the network still works. So if one computer goes down and their connection goes, everyone else can still work. And there's a lot less cables, but it's less cost of cables. So you need to be clear, because it does say there, you can't say it's cheaper or it's faster. You need to kind of qualify that by saying it's less cost of cables. Why is it cheaper? Because you're buying less cables. And a drawback, if the switch fails, then everything fails. Extra cost of the central device or the switch. Although, to be honest, that's not a massive amount. Okay, so next question is describe the role of the switch in the star topology. 3 marks. What does the switch do? I have mentioned some of it already. So the main thing that the switch is doing is it's making the network, all the devices on the network talk to each other. So it's transmitting messages between anything connected to it. And that is kind of like the most central role. It uses usually the MAC address of the devices to send messages to it. Let's have a look at the answers. We've got maximum of 3 marks, connects the devices in the network or allows devices to communicate in the network, receives data from all devices in the star topology, records, registers, stores the address of devices connected to it in a table. It's a lookup table, uses MAC address of the devices, directs data to its destination, and if the address is not recorded, it transmits to all devices. So the difference between the hub and the switch is a hub will send, if it receives a message, it sends it out to everybody, but a switch will kind of say, oh, okay, it's for that particular computer. So it's a little bit more intelligent than a hub. Okay, next question. A computer has an operating system and utility software. The table contains operating system functions and a task that each function performs. Complete the table by writing the 2 missing function names and a task performed by the 2 given functions. Okay, so we've got function, we've got peripheral management. What is the task there? And we've got user interface, and then the task is moves data from secondary storage to RAM and then allows the user to create, name and delete folders. So we have a look at the answers for this. It moves data from secondary storage to RAM is memory management or managing memory. Peripheral management, you can put any of these 4 bullet points, receives data from input devices, transmits data to output devices. Remember, peripherals are things like printers or scanners or anything that you connect to your computer that is sort of inputting. Installing, downloading device drivers. Device drivers, remember, sit in between your computer and the peripheral or the device so that they can communicate with each other. And it's just a little piece of software that's put onto your computer to manage it. Allows communication from input device to the output device. Then what is it that allows the user to create, name and delete folders? It's file management. And then if we're using an user interface, any of these bullet points, outputting data to the user, receives input from the user, allows the user to communicate, interact or control the computer, creates displays, allows interaction with a graphical user interface, command prompt interface. And just a quick note, a few here, allow for peripheral, so BOD storage for memory in the first function, allow input and output devices by example, file management, do not award folder management, so it's always files, not folders. And the task for peripheral management needs to extend manage, so it's not just managing, it's outputting, so try and expand everything, be a bit more specific if you can. Okay, next question. Complete the description of utility system software using the words provided in the box. Not all words are used. So we just fill in the blanks. Pause the video and see if you can get these. So the first one, it is encryption software. Let's get it written on there. Encryption software changes data using a key. So that means that if the data is intercepted, it cannot be understood. So you can read it, but you might not understand what it said because it's going to be, it's going to be put through encryption, so you're not going to be able to understand it. This software does not stop the data from being intercepted. So something software analyzes the data on a disk. So it is defragmentation, big word there, defragmentation software. Analyzes the data on a disk to find files that have been split and stored in separate locations. The split files are moved to be consecutive in storage, and the free space is moved together. This does not provide more storage space on the disk. Instead, it makes the speed of the data faster, or sorry, the access, not speed, the access of the data faster, because the read head does not have to move as far. to access the next part of the file. And if we just have a look at the answer there, yeah, we can see there, it's just encryption key understood, defragmentation, consecutive access, mark first answer in each space. Okay, next question. We've got a blank page there in the booklet. Okay, so this is 8 marks. So for our 8 marks, we've got quite a lot of space here, and we're discussing, so it says a computer programmer has developed a computer game that they want to release for users to download over the internet. The programmer needs to decide whether to release the game as open source or proprietary software. Discuss the features, benefits and drawbacks of each type of license for this program and make a recommendation for the programmer. You should include the following in your answer: the features of each license, legal and ethical issues of each license, benefits and drawbacks of each license. So they've given you a really good framework there of what to do. So all you need to do is address those bullet points and make sure that you've answered them for each one for open source and proprietary software. Now, if we think about it does say sort of discuss the benefits, and they need to decide. You can pick either side, and you must make a recommendation. So as part of this, you can't sort of sit on the fence. Don't sit on the fence about this. Pick one. And actually, if we see in the mark scheme, it doesn't matter which you pick. They just want you to sort of justify it, and it depends on what the person wants. So let's have a think about those two. So open source is free. You're giving away your code free, basically. And there are issues with that, because obviously if you're giving your work away free, you're not going to get up front anyway any money back from that. So what is the reason that the programmer wants to release the game? Are they just doing it as kind of like a, hey, I've done this work and maybe someone will employ me in the gaming industry if they see my fantastic code and what I've done? Or maybe they want to make money and they want to actually get money from that. So in that case, it needs to be proprietary software and they're charging for it. So let's have a look at the mark scheme. It's probably going to be easier if we do that. And each, they've got bandings here, but what we'll look at is actually the guidance. So it does say here indicative content. So the license features are open source is usually free, and you can access and change the source code and you redistribute it. Whereas proprietary, you purchase it at a cost and you cannot change the code or access the code. So the legal and ethical issues, they both have copyright. Open source allows more people to take the code and change it and resell it or adapt it in their own programs to resell. And they could then charge for that. And then obviously the reverse for proprietary is they can't take the code, they can't resell it, they can't adapt it. Open source allows more people to access the game because there is likely no cost. And again, it's with proprietary, less people are going to access it. Benefits and drawbacks: open source is wider customer base. You get more exposure. Users can alter and make it better. You can there'll be limited documentation and there is little financial gain. Well, there's little financial gain up front, but like I said, if you're using it to kind of showcase your work, then you might want to still use it. Whereas proprietary software allows the programmer to earn more money, gives more control over what happens, who can have it, how it's tested. There's restrictions for copyright, and it cannot be adapted to meet the user's needs. So those are the sort of points that you're going to put. And again, if you don't put any answer, then you're not going to get any marks. But you can always try and put down what you can, because, if you can't remember one or the other, always try and put something down, because even if you get 1 or 2 marks, that you've done very, very little, you can still get 1 or 2 marks, and that could be the difference between getting a higher grade. So do try and think about writing down as much as you can and do it in a structured way. So what they're looking for the full marks, a candidate demonstrates thorough knowledge of it, but you're weighing up both sides, always considering both. You cover all the requirements, all 3 bullet points, and you include a recommendation. So that recommendation must always be in there, but with your justification. It says the top of the band makes a clear and structured recommendation to the programmer. Okay, on to question 5. A musician uses a computer to make and record music. Tick one box to identify the correct description of sound sampling. Is it the frequency of the wave is measured a set number of times each second? The amplitude of the wave is measured at set intervals. The digital sound wave is measured to a set number of times each second. The analog sound wave's resolution is measured at set intervals. So these are very similar to what sampling might be. So read them carefully, pause the video. Well, the correct answer for this one is the amplitude of the wave is measured at set intervals. So if you're sampling sound, it's definitely not this one here, because the third one, the digital sound wave, is measured a set number of times. It's not digital at that point, it's analog, so it's definitely not that one. And the analog sound wave's resolution is measured at set intervals. There's no resolution for analog sound, so it's not that one. Resolution is to do with digital. And then, so the only other one it would be that's really close to what it is the frequency of the wave is measured a set number of times each second. Well, that is almost, it's not the frequency, it's always the amplitude. Because if you think about a sound wave, it has an amplitude, it's not the frequency, so it's only got to be that second one there. And then the next question, explain how changing the bit depth will affect the sound file. So every time that we're making a sample, we are checking the amplitude, and we have a set number of bits. If we go from like 8 bits to, so 8, 1, 2, 3, 4, 5, 6, 7, 8 to 16, so that's double. I think that's 16. How is that going to affect the sound file? Well, obviously it's going to at least double the size of the sound file, so it's going to make it larger because you're storing. And why is that? So it's going to be larger because it's more bits that you're storing. Effectively, it should double it. Let's have a look at the mark scheme. What do they say? Let's see if there's anything I've missed off. And yeah, so the number of bits per sample will change. So you can give an example. The file size will change. It will increase or decrease. It will increase in this case. There will be a change in the accuracy of the sample. So the sound file will store more bits, so it's going to be more accurate, and the quality will change as well. The quality is going to be better. So here in the notes, they've got MP3, so marking point 3, there will be a change in the accuracy. Not that there are more amplitude samples per second. Yeah, so we're not increasing the number of samples, we're just increasing the accuracy of those samples. More amplitudes can be measured, but more amplitudes measured per second is incorrect. By the way, I probably should have mentioned this before. It does keep talking about BOD. BOD stands for benefit of the doubt. So basically, benefit of the doubt, sound for amplitude. So you're basically, they're assuming that you know what you're talking about if you put sound instead of amplitude. Okay, next question. The musician has run out of storage space on their secondary storage device and needs to buy a replacement. Identify whether the musician should buy magnetic secondary storage or solid state secondary storage for their computer. Justify your choice. Now for this question, they don't care which you pick, magnetic or solid state, you just need to justify it. And it could be, yeah, you just can only remember one of them and you decide that's the one you're going to go with. That's absolutely fine. So you get 1 mark for, well, you don't get any marks for the type, you just get, because they've put those types there, so 4 marks for the justification. So let's just have a look at the mark scheme actually, because there's many benefits. Just remember that with magnetic storage, it's usually cheaper because it's cheaper to manufacture. Solid state storage is more expensive, but there's lots of other reasons. So magnetic, like I said, is cheaper per unit, but it's got better. It's got good durability. It's unlikely to move. So you're not going to move regularly. Sufficient fast speed of access. It can be, it is slower than solid state, but it's good enough normally. Long term, it's reliable. It's got longevity. It's you're unlikely to need another. And they can break, but yeah, it's unlikely to break for overuse. high capacity because it is cheaper, so you're going to get a lot larger for your money, and the file size can be large, so that means that they can store a lot of files. Now with solid state, it's often more expensive per unit than magnetic. It's very durable, there's no moving parts, whereas with magnetic it's got a read-write head and spinning disks that are moving, so it's very durable. It's very fast because it's using chips instead of having to move a disk. No significant delays when you're storing. Does have high capacity. You can get as high as magnetic, but it is just more expensive. So you can store it. It's small in physical size, so it's portable. Produces less sound when running, so the musician is distracted. So yeah, magnetics can, if they, they're not supposed to make too much sound, but they can do. Little or less power for solid state, and the drives do not get fragmented. So we looked at defragmentation in that previous question. Yeah, that can be an issue, but you don't have that with solid state. So the next part of that question, it just says identify one other type of secondary storage. So the other type of secondary storage is optical, or so CD-ROM, DVD-ROM, or Blu-ray as well, can all be used as storage, not just for sort of games and videos. But yeah, optical is what we're after. You can put, if benefit of the doubt, BOD, optic. So yeah, if you put optic. Do not award an example of optical storage. So this is a really important point here. So if you put a CD-ROM, then they won't give you a mark. You've got to identify the type. Does it say the type in there? Yeah, it does say the type of secondary storage. So, if they said a sort, not a type, but a device, then you could have put CD-ROM, but they said a type. So these are the little things that you need to be aware of in the mark scheme, as I keep saying. Okay, next question, tick one box to identify the smallest secondary storage capacity. Okay, so let's have a look at these. Let's have a think about our data sizes. Remember that we've got different data sizes. We've got bytes, we've got then kilobytes, which is 1,000 bytes or 1,024 bytes. We'll stick with 1,000 bytes. We've got megabytes, which is 1,000 kilobytes. We've got gigabytes. Have we got any gigabytes here? We have got gigabytes, and we've got terabytes. So each one goes up by 1,000. And then a terabyte is 1,000 gigabytes. So basically, the smallest one is, so 2.1 gigabytes is not smaller than 300 megabytes. So far out of those two, this one is smaller, 300 megabytes. So it's definitely not that one. Only tick one, by the way. If you tick more than one, you will not get a mark. And only tick, don't put crosses like I have. I've just put crosses in just to show you what the right answer is. So if we think about 0.21, we've got 3 zeros there. So if we times that by 1,000, that's going to move the decimal place by 3 times, I think. So that's going to be 2.1 gigabytes. So that's the same as this one here. So that's not the smallest. Is 200,000 kilobytes less than 300 megabytes? So if we divide that by 1,000, so that's 1, 2, and then 3. So that's 200 megabytes. So because I've divided by 1,000, so actually this is the smallest one because that's actually 200 megabytes. So that is the smallest one. So the answer is, if I get rid of the markup there, the answer is 200,000 kilobytes. So all the time you're just dividing by, or dividing by 1,000. Get rid of those zeros, 3 of them, remember, and you can work out which is the smallest. Okay, next question. Oh, we haven't looked at the mark scheme for that other one. Yeah, 1 mark for 200,000 kilobytes. And if you tick more than one, then you're going to get 0 marks. And then we're working out a file size here. A musician's recording have an average file size of 3 megabytes. The musician has 1,000 recordings. Calculate an estimate of the storage space in gigabytes that the 1,000 files will require, assuming that they are 3 megabytes in size. Show your working out. So if we've got the average size is 3 megabytes and they've got 1,000 recordings, three times 1,000. Sorry, my graphics tablet is so slow. It's very annoying. Calculate an estimate of the storage space in gigabytes that the 1,000 files will require, assuming they are 3 megabytes inside. So it's 3 times 1,000, which is 3,000 megabytes. And if we divide that by, so 3,000 megabytes, remember that 3,000 megabytes divided by 1,000, that will give us the gigabytes. So it's basically 3 gigabytes. So nice, easy calculation there. And if we have a look at the answer, let's get the answer sheet up. There we go. And we've got, yeah, it's 3 gigabytes there. And any kind of working, there's a number of different ways you could work that, but the easiest is just 3 times 1,000. In the mark scheme, it does say allow 2.2929685 for, or approximated for division by 1,024. So that's fine. Allow addition of metadata, e.g. 10% added. This can be awarded for both working and answer. So remember, every file has metadata in it to tell you what the file is. It's in the header of it. Not all of the working needs to be correct to get the working mark. Ignore mention of megabytes, gigabytes in the working. Okay, so we've still got a few questions to do, but we are nearly there. There's only 2 pages left, so well done for getting this far. A computer has a central processing unit. Describe what happens during the fetch execute cycle. 2 marks for this, which I think is quite low. What happens during the fetch execute cycle? Okay, let's look at what happens. Well, I mean, there's so much that you can say about the fetch execute cycle, but yeah, they've got data instructions are fetched from memory or RAM or primary storage. Data instructions are stored using registers, or a correct example of a register, so you can give like the memory address register, etc. Data instructions are decoded. Data instructions are executed or processed. The arithmetic logic unit performs the logical arithmetic calculations. So it says the benefit of the doubt carried out for executed, ignore inaccurate references to registers and components. So just be really careful what you say. So yeah, data instructions are fetched and then executed and processed. That's what I would probably put for that one. Complete the table by writing the name of 2 registers used in the fetch execute cycle and the purpose of each register. So there's quite a lot to choose from. And you get 1 mark for the register name, 1 mark for the purpose. So you can still get marks even if you can just only get the register. So let's look at the mark scheme. And lots of registers to choose from. So we've got the program counter, which stores the address of the next instruction to be fetched. Memory address register, which stores the address of the current instruction to be fetched. The memory data register stores the data instruction of the that has been fetched from memory, and the accumulator stores interim results from the arithmetic logic unit. So in the notes there, it says careful that the purpose is not an action such as fetches, takes, retrieves. Read the full purpose and award the correct point. So basically, you can also accept the current instruction register or the instruction register and stores the instruction which stores the instruction currently being executed. BOD, so benefit of the doubt, memory buffer register for the MDR instead. If there's no register, but the register is given in the purpose column, award if the purpose is accurate. For PC and MAR, accept pointer for storing message address, accept memory address, memory data. So try and get it as accurate as possible, and that will get you the maximum amount of marks. Funnily enough, who knew that? Give 3 characteristics of a CPU that can affect its performance is our next question. So what about the CPU can affect its performance? So there is, good amount of stuff that we can put here. Let's look at the mark scheme. We've got clock speed, so that's how fast it is, how fast it does the fetch execute cycle. The cache size, so this is memory that's attached to it. That's really important. How much, sort of MDR has it got so that it can store things very close to it. And then the number of cores is the next one. It says clock cache speed cores on its own is not enough. So you can't put speed, can't put clock, it needs to be clock speed, can't be cache size. So always kind of qualify it, try and be as accurate as possible. And don't put cores on its own, it needs to be the number of cores. So again, try and be as specific as possible. Okay, we're on our final page. A car has a follow me system that uses a cruise control feature to allow the car to follow the car in front of it. It will keep the same speed and distance without the driver's intervention. Not sure I'm liking this. If they crash, you might crash. The cruise control system is an example of an embedded system. Explain the reasons why the follow me system is an example of an embedded system. So what is an embedded system? And let's look at the answer for this. Well, an embedded system, it has a specific purpose and it's built in. So that's one of the main things, is it's built in into a larger device. So like a vending machine is an embedded system, washing machine, etc. It has a microprocessor. It's built in, has a built-in operating system. It's all in firmware or the ROM. It has instructions or operations are hard to change, and it's a control system or it's automated. So it has a specific purpose as well, is another one. And benefit of the doubt, it says reference to it being built into something reasonable. The car system has read-only memory and random access memory. State 2 items that will be stored in the ROM for the follow me system. So what would we store in the ROM? So the RAM will store currently running data and instructions. State 3 items of data that will be stored in the RAM for the follow me system. So what do we actually store in RAM? And that is the current distance from the car in front. So this is just an example, so it could be anything like this. Set distance from the car in front, the current speed of the vehicle, the current speed of the vehicle in front, a reading from a sensor, the driver's actions, the direction of the car. If you put something else as well, that's fine. It's an example. But reference to a camera taking images of what is in front, that can be put in there as well. If you just put speed or distance on its own, it's not enough. It needs to be, the car in front, what's going on, or the speed of the vehicle in front. And then the final question, explain why the follow me system does not need virtual memory. So remember that virtual memory is where we use part of the hard disk to instead of RAM, because we've run out of RAM. And the answer is it only stores a small amount of data in RAM for a few specific items. It's unlikely to run out because there should be enough RAM. No secondary storage is used anyway. But no secondary storage. So the whole point of that one, third one, no secondary storage is there at all. There wouldn't be any secondary storage because everything is in the ROM. A few or one program instructions at a time, so it's not memory intensive. Dedicated hardware will be optimized for the system, and the RAM is designed to meet the system's requirements. So because it's embedded, it's not like a PC where you can install software that kind of needs more RAM than your computer has. it should have been built specifically for that problem, and therefore you just don't need it. Okay, that is our final question. That was quite long, so well done for getting this far, and I hope that helped. Do like and subscribe, and I'll see you in the next video.